Hello everyone, today I want to introduce a technique, the ultraviolet visible spectrophotometry. Abbreviation is UV-Vis, and I mainly focus on how to use this, the UV-Vis. As we all know, there are many kinds of wavelengths of light, and all of them are called the electromagnetic spectrum. From this picture, we can see that the wavelengths from the larger to the smaller ones are the radio, microwave, infrared, visible, and ultraviolet, X-ray, and gamma ray. This line vividly shows the different wavelengths of different spectrum, and the frequency at the bottom shows the magnetic field of the wavelengths. It's largely varied from the magnetic 4 and 20. So today I will mainly focus on the visible and ultraviolet. UV technique is mainly use these two wavelengths of light to get absorption spectrum, and the range of these two is about the 20 nanometer to 800 nanometer. And UV violet visible spectroscopy refers to absorption spectroscopy or reflectance spectroscopy of the ultraviolet visible spectral region, and this kind of the electron transmission is normally are the pi electrons or non-bonding electrons transmitted to the antibonding molecular orbitals. So due to this characteristic, molecules with pi electrons are easy to have the UV spectrum. So to detect that kind of molecule, we usually use UV, and this picture simply shows the schematic of UV visible spectrometer. And from this picture, we can see there are several main components of the technique. One is the light source, the lamp, the two lamp, and another is the monochromator and the beam splitter, and finally the detector, the two detectors. And from the picture we can see the light compares through there, and through the monochromator we can get the selected wavelengths we wanted, and then we double the beam, use the beam splitter, and this aim of the double beam is to have the reference compared to the sample, so to get the more accurate results. And these two are both detected by the photodiode, the two detectors, and they are conduct at the same time, and finally they come to the data processing using the computer. And the most important principle of the UV visible techniques are the Langmuir law. From this formula we can see the absorbance of the molecules have a linear relationship to the concentration. C refers to the concentration, and this is the absorption coefficient, and this is the sample length, the sample container length. This length refers to L. And next I want to show you the real ultraviolet visible spectroscopy, and this is over the spectrometer, and there are two main components. One is the UV. The structure inside is the same as the front page ones, and this is computer to connect it to the UV to process the data we get. And this is the the sample container to for light to transmit it in, and then through it, then we detect the absorbance of the light, and then get the spectrum of the different molecules. And this sample container called the QVAS. And from the picture, we can see there are many kinds of QVAS selected due to different molecules or different equipments. And this is the inside part of the UV. The sample container is put inside here, and then the overall system containing the light then goes through the sample container, and then come to the detector, and then connect to the PC. And lastly, I want to show you an example of the UV spectrum. This picture shows the absorption spectrum of the molecules. And the molecular, from the picture we can see that they are they are full of pi electrons, and this is correspond to the basic concepts. The pi electrons transition to the antibody high energy levels, and we can see the maximum lambda is 260. This shows at this wavelength the UVVs absorb the molecules most. So we usually make use of this characteristic to detect the different molecules with different absorption wavelengths. This picture is this molecular is commonly seen the NAD, the ion, positive ion. So that's all. Thank you.